Welcome to your deep dive into the world of Kubernetes. You've given us a stack of articles about this stuff, especially about managed services,
Yeah.
AKS, EKS, and GKE. So we're going to try to break down how Kubernetes works.
It's really become the standard for managing applications. Like everyone is using it these days.
Yeah, one article dug into that. It talked about how Kubernetes came from Google. Like it evolved from their internal system called Borg, but it wasn't just some side project.
Oh, no. Google was already using it to manage this massive infrastructure. Even way back in the early 2000s,
Wow.
they were way ahead, like figuring out container orchestration at that scale. But the really key thing was open sourcing Kubernetes back in 2014. That's when they made it available to everyone.
And that kind of kicked off this whole industry standard thing.
Yeah.
Now you've got Microsoft with AKS, Amazon with EKS, Google's own GKE, all offering managed Kubernetes services.
Mm-hmm.
So did Google accidentally create their own competition?
Makes you wonder, right? But it also shows how well-designed Kubernetes is. It can run on pretty much any infrastructure.
I guess that's why it's everywhere. It's wild to think about. This tech that came from Google, now it powers so many of the apps we use every day.
Yeah, it's a great example of solving a really tough problem, and then it revolutionizes a whole industry.
Okay, so let's get into how it actually works. One article had a really good analogy about shipping containers.
Ah, yeah. So the containers are like the packages, they hold your software, and those containers get transported on ships called nodes.
Right. So what's Kubernetes doing with all these containers and ships?
It's like the orchestra conductor. It makes sure those containers are running smoothly, like where they should be, which nodes they should be on. It can even move them around if there's a problem.
So with Kubernetes, I don't have to worry about what each individual container is doing.
Not really, no. You can focus on the big picture of your application, and Kubernetes manages all those containers at scale.
That makes sense. And that brings us to these managed services, AKS, EKS, GKE. It's like Kubernetes on autopilot, right?
I like that analogy. Yeah, they take care of the hard stuff, like setting up infrastructure, scaling things up and down, making sure things are always available, and keeping everything secure.
That sounds pretty amazing. But what's the difference between them? I mean, why would I pick one over the other?
That's where the details matter. If you're already using a lot of Microsoft Azure, then AKS is going to integrate smoothly. EKS, on the other hand, it lets you tap into AWS's massive infrastructure.
And GKE. Well, that's Google's own. It must have something special.
They've definitely put all their Kubernetes knowledge into it, all their innovative features.
It really comes down to my needs
Yeah,
and what I'm already using.
exactly. There's no one best option. It's about choosing the right tool for the job. But whatever you choose, you'll discover there's a whole set of advanced Kubernetes features.
Oh, all right. So let's unlock some of those advanced features. One of the articles mentioned a service mesh.
Oh, this one is interesting. Think of it like the traffic cop for your application, especially if you have a microservices architecture. The service mesh keeps that communication flowing, makes sure it's secure, and gives you a way to watch what's going on.
So it adds more intelligence and control to how my application is communicating.
That's a good way to put it. Then there's ingress. That's more like the front door to your application.
So directing all the incoming traffic.
Yes, exactly.
Yep.
Like a receptionist who makes sure visitors end up in the right department.
Okay. Now, what about persistent volumes? The article I read made a big deal about stateful applications.
Right, because that's what persistent volumes are all about. Providing a place for stateful applications to store data. Things like databases. It's like a dedicated storage for your most important information.
What's so special about stateful applications?
It's the difference between a note scribbled on a napkin versus a document you file away. Stateful applications need to remember things.
Okay, so persistent volumes give them that long-term memory.
Exactly. And speaking of making things reliable, there's Helm. It simplifies deployments.
One article called it the package manager.
Yeah.
What does that even mean?
Imagine building furniture without instructions. That's what deploying applications can be like without Helm. It gives you a structured way to define things, install things, manage all the resources in your application.
So it's bringing order to chaos.
You could say that. And then there's network policies. They're all about security. Think of them as the guards, controlling who can talk to whom inside your Kubernetes cluster.
So like a firewall.
Very similar, yes. You
Yeah.
wouldn't leave your house unlocked, right?
Right.
Network policies help lock down your cluster. They prevent unauthorized access.
We've covered a lot already. How Kubernetes came from Google, how it works, and even some advanced features. What's next?
Now we can get into scaling, how Kubernetes handles the demands of modern applications, applications that need to grow and shrink dynamically, That's where the real magic of orchestration comes in.
So how does this scaling actually work?
Oh, it's pretty impressive. Imagine your application automatically growing and shrinking just based on demand.
So if my website gets a ton of traffic, Kubernetes just handles it.
That's the idea. There are a couple ways it does this. One is horizontal pod autoscaling, or HPA. It keeps track of things like CPU or memory usage, and if it needs to, it spins up more pods.
So it adds more copies of my application.
Exactly. Then there's vertical pod autoscaling, or VPA, and that adjusts the resources that each pod gets. So if a pod is overloaded, it can be given more CPU or memory.
So HPA has more pods, VPA makes the pods more powerful. It's like having a team that can hire more people and give them better tools at the same time.
I like that. Yeah, and these features work together to make sure your applications can handle the workload.
This is all making sense. But the articles also talked about stateful and stateless applications. What's the difference?
It's a key concept. Stateful applications need to remember things. They keep track of data and their own identity. Think about a database. It needs to store information,
Yeah.
even if the application restarts. Stateless applications, on the other hand, don't need to remember anything between requests.
So a stateless application treats every interaction as brand new.
Right, like a web server serving up static web pages.
Makes sense. So how does Kubernetes deal with these different types?
For stateless applications, it uses something called deployments. This is what makes sure you always have enough pods running, even if some of them fail.
So it doesn't matter which pod is handling a request.
Exactly. And if a pod fails, Kubernetes can just spin up a new one.
Okay.
Stateful applications are more complicated.
Because they need to keep their data safe.
Exactly. For that, Kubernetes uses stateful sets. Those make sure each pod has a unique identity and that it's always connected to the right storage.
So stateful sets are like giving those applications a dedicated home.
That's a good analogy. They also handle things like updates, making sure they're applied in the right order.
Okay, so to sum it up, deployments are for managing stateless applications, and stateful sets are for stateful ones. How does this all work in a real-world scenario?
Let's go back to that e-commerce platform. The product service and the order service, each running in their own pods.
Yeah, and I'm guessing those advanced features, we need some of those to make this work.
Definitely. First, we need to make sure those services are accessible. That's where services come in.
So a service gives the pods a public address.
It's more than that. It provides a stable endpoint, even if the pods themselves are changing. Remember how we talked about HPA and BPA?
Yeah.
Services make sure there's always a way to reach those pods.
So even if pods are being created or destroyed, the service is always there.
You got it. And then we need ingress to route traffic to the correct service. So requests for products go to the product service, and requests for orders go to the order service.
Like a traffic cop directing cars.
Exactly. But what if we have multiple pods for each service?
Right.
That's where load balancing comes in. It spreads traffic evenly across the pods.
Make sure no single one gets overwhelmed.
Right. Then there are secrets. They're a way to store sensitive information, like database passwords or API keys.
You don't want that stuff mixed in with your code.
Exactly. Now, what about the product information? Where does that get stored?
That's where those persistent volumes come in.
Exactly. We'd use those to provide the storage space. And then persistent volume claims to request that storage.
So it's like saying, hey, I need some of that storage for my data.
Yeah, and the last piece is config maps. These are for managing config settings for our services, things like timeout values or connection strings.
So we don't have to change the code every time.
Right.
It's like a central control panel.
Precisely. So we've walked through a simplified example of building an e-commerce platform with Kubernetes. All these concepts, they come together to create a scalable application.
It's amazing.
But wait, there's more. Have you heard of Kubernetes operators?
They sound familiar. What do the articles mention them? What are they all about? So they're like a way to automate even more.
Yeah, you could say that. Imagine a team of experts who know how to manage complex applications. Things like databases or message queues.
That sounds almost too good to be true.
Well, they're like specialized software engineers. Built into Kubernetes, they package up all that knowledge and can automate really complicated tasks.
Give me an example.
Sure. Let's say you're running a MySQL database, a MySQL operator. It would know how to handle backups, scaling the database, even failing over to a replica.
So it's like having a dedicated team, always making sure my database is running.
You could say that. And in cloud environments, like AKS, EKS, GKE, these operators can integrate with cloud services.
Oh, so if I'm using AKS, There might be an operator for Azure.
Exactly. And you could have a different one for AWS. It brings that expert level automation to all your components.
This is really impressive. But what about managing multiple Kubernetes clusters? Like, what if I have applications running in different environments?
That's where Kubernetes Federation comes in. It lets you manage multiple clusters as one.
So instead of jumping between different tools, I can see everything in one place.
That's the goal. Federation can simplify things. Deployments, scaling, monitoring, across all your clusters.
It sounds like a game changer for companies using multiple clouds.
It definitely makes managing that complexity easier. Federation provides a unified control plane.
We've covered so much. The history of Kubernetes,
Yeah.
how it works, advanced features, even operators and managing multiple clusters.
It's been quite a journey, and remember, this is just the beginning.
It feels like you've given me a map and a compass. Now it's up to me to explore.
Exactly. What stands out to you most? What are you curious about?
Honestly, it's the potential that excites me. Kubernetes is so powerful. But I know it's not a magic bullet.
No, of course not.
There are going to be challenges.
Absolutely. What would you be most concerned about if you were to build an application with Kubernetes?
Probably choosing the right tools. There are so many options. It can feel overwhelming.
That's a valid concern. Start with a clear understanding of your needs, and then choose the right Kubernetes features.
And I guess staying up to date is important. Things seem to change so fast.
That's true. The Kubernetes ecosystem is always evolving, but that's also what makes it exciting.
This has been so helpful. Thank you for guiding me through all this.
You're very welcome. There are so many resources available. Don't be afraid to ask questions and dive deeper.
I will. This has been a fantastic deep dive into Kubernetes. I'm ready to get started.